Next thing is conjugates. So we have conjugate acids and conjugate bases. Once we've identified what our conjugate or what our acid is, a conjugate acid is what a base looks like after gaining a hydrogen. And so if we have whatever our base is, the base is going to, through that reaction, become a conjugate acid as it has gained a hydrogen. If we look back at this example here, here's our Bronsted-Lowry base. By gaining a hydrogen, that H3O in this case is the conjugate acid. And then our conjugate base would be what our acid becomes after it has lost that hydrogen. And so this would be the conjugate base to that H2SO4. So conjugate acid, that's what a base looks like after gaining a hydrogen. So whatever that base looks like, gaining a hydrogen. Conjugate base is what an acid looks like after it has lost that hydrogen. So HCl, if it loses that hydrogen, it's going to just be that Cl minus 1. And one thing to note is that this was neutral. And so when this HCl loses the hydrogen, which has a positive charge, that's going to leave the chlorine with a negative charge. Just like this base here, OH minus 1, by gaining that hydrogen, that proton, that H plus, with that OH, then that becomes neutral when we do that drop and swap to get that HOH or that H2O. So acids become conjugate bases. Bases become conjugate acids through the reaction. So let's look at these. So determining the conjugate base, and a conjugate base is what an acid looks like after the hydrogen is lost. So we have an acid, and it is going to lose an H plus. And so this is neutral. By losing that H plus, losing that positive, we're going to be left with just fluorine minus 1 when that H is lost. Looking at this next, and then F, fluorine minus 1 is the conjugate base. H3PO4, as that loses a hydrogen. Well, if we get rid of this hydrogen, which has a positive 1 charge, we're down to only 2 hydrogens, H2PO4, and then this whole grouping, because it lost a positive, is going to have a negative charge, a charge of negative 1. H3O plus, if it loses a hydrogen, we're going to have H2. So remember, we have an H plus is being lost, so we're going to have an H2O. Well, this is a positive, and so that means this plus 1 charge is going to have to go down to being neutral. And so this would be a charge of plus 0, which we would just write as neutral. We wouldn't write that charge. So by losing a hydrogen with a positive charge, whatever you're left with, that charge is going to go down by 1. So we had neutral fluorine going down to fluorine minus 1. This was neutral down to minus 1 with that. If we took, let's say, that H2PO4 minus 1, if that was an acid, then to determine the conjugate base, to go down to H, losing one of those, HPO4, well, this is already at a minus 1, and so then that would become minus 2 as it loses another H. All right, determining the conjugate acid. So if we have the conjugate acid is what a base becomes when it gains a hydrogen. So if we have Br minus 1, well, if this is gaining a hydrogen, this is kind of like writing that compound. We have H plus and Br minus 1. Well, drop and swap by gaining that hydrogen, our charge is going to go up 1, and so then that becomes neutral. HSO4 minus, well, if we gain another hydrogen, so if we're going to add another H plus on there, that's going to be H2SO4. We had a charge of minus 1, and now we're adding a charge of plus 1, and so then that makes this a neutral charge, which we wouldn't necessarily write. If we have CO3 with a -2 charge, this means the same thing if it was just -2 or 2 minus. So whatever you prefer, we see it both ways. So if we are gaining a hydrogen to become a conjugate acid, then we're going to have HCO3. The H is going to go first. H always goes first because it is less electronegative. And then we had a -2 charge. This is a +1 charge, so -2 + 1. So this would still have a -1 charge after that hydrogen is added. So you could do -1, or you could just leave it as a minus. All right, so conjugate pairs, we can see those conjugate pairs in our reactions. And so the products of an acid-base reaction are called those conjugates. And so the acid becomes a conjugate base. Once that H plus has been donated, the base becomes a conjugate acid once that H plus or that proton has been accepted. And so if we have this NaOH, we can identify by that OH that this is a base. Well, how is that OH changing? That base, that OH is gaining a proton and it's going to become that conjugate acid. So bases become conjugate acids. That HCl, we can see we have a hydrogen, identifying that as an acid. Well, acids lose or donate, so that Cl has lost its hydrogen, and so then that Cl becomes a conjugate base. Like that. Looking at this H2O plus HNO3 producing H3O plus NO3 minus, well, as we look at this, that H2O and that HNO3, as I see that HNO3, looking at that, HNO3 becoming NO3 minus, so that is losing or donating a hydrogen, which is how we can see that that HNO3 is our acid. So NO3 minus is our conjugate base. What that acid becomes after the hydrogen has been donated. H2O is our base in this case because it is gaining a hydrogen, and so that base is going to become the conjugate acid. Here are some examples for you to try on your own. For each of these reactions, classify the acid, the base, the conjugate acid, and the conjugate base. I'm going to do the first one, and then you can pause the video and check your answers for 2 and 3. Feel free to try all of them on your own. So looking at classifying the acid and the base, let's look at those first. So again, my acid has a hydrogen to donate. Both of these have hydrogens. And so now I'm going to look at, well, how are they changing? Which one is donating the hydrogen? So if I look at that ClO2, well, here I have a ClO2 that has lost that hydrogen. And so because that ClO2 donates a hydrogen, that makes that our acid, which would make our H2O the base. When an acid donates a hydrogen, what's left is the conjugate base. When a base gains a hydrogen, we see that we have H2 now to H3. So that base gains the hydrogen or that proton, that H plus, and that makes this the conjugate acid. So your acid and base are always going to be your reactants. Your conjugate base and your conjugate acid are always going to be your products. Pause the video and try 2 and 3 on your own, and then come back to check the answers. All right, here are the answers for these. We've got the base is ClO minus plus H2O is our acid, with that HClO as the conjugate acid and the OH hydroxide ion as the conjugate base. And then we've got our acid, that HCl, with the H2PO4 as our base. That HCl loses the hydrogen to become the conjugate base of chlorine, and then that H2PO4 gains the hydrogen to become the conjugate acid. The next video will go on to the next part of the slides, which is on naming. There is practice on conjugate pairs on the provided worksheet. Reach out to your teacher with any questions.